Hydrogen bonding. Hydrogen bonding is a type of dipole-dipole interaction that occurs when a hydrogen atom covalently bonded to highly electronegative atom such as fluorine, oxygen, nitrogen that interacts with the lone pair of electrons on another electronegative atom. H2O. This is the water molecule. Here you've got the oxygen, hydrogen, and another hydrogen. Now, this oxygen is electronegative. What do you mean by electronegativity? That is electron withdrawing tendency. It means it can grab the electron from bond. For example, you have got this OH, and now because of the presence of electronegative atom, it can withdraw the electron from hydrogen. So that is why it is called electronegative atom. In a periodic table, this electronegativity increases from left to right and decreases in a group from top to bottom. Okay. So in that case, you got at the extreme right side helium, neon, argon, krypton, xenon, but they are inert gases because they are completely filled with the orbitals. So they are not so reactive. But the next to that is you've got halogens which are represented by X. So you've got fluorine, chlorine, bromine, iodine, astatine. So down the group, the electronegativity decreases. It means electron withdrawing tendency. And the electropositivity increases. So that is why electronegativity is called non-metallic behavior. Whereas electropositivity is electron releasing nature, electron releasing tendency. What about electronegativity? This is electron withdrawing tendency, that is non-metallic character. Electropositivity means electron releasing tendency. As in the case of sodium, it releases one electron to become Na plus. That is the very behavior of what? Metal. Whereas non-metals like chlorine, they take the electron from the bonded pair so that it becomes a Cl minus. So this is the electronegativity. I hope now I have clarified the difference between electronegativity and electropositivity. Now you've got a molecule water where you've got the electronegative atom. This electronegative atom is capable of developing a bond with the hydrogen. It can be either within the same molecule or with another molecule. For example, you have got hydrogen here and O. Now, this is another molecule of water where you have oxygen, hydrogen, hydrogen like this. Now, there is a development of bond. So this is of electronegative nature. So it can withdraw electron. Okay. So delta minus. And this is delta plus because hydrogen is electropositive in nature. So it doesn't have bond of its own after giving a share with the oxygen. And now there is an interaction between the electronegative atom and the nearby proton to form proton means here hydrogen. So to form a hydrogen bond, and that is indicated by the dotted line here. So this is called H bond. So when this H bond takes place between two or three molecules or among the molecules, it is called intermolecular hydrogen bonding. Okay. And if it take place within the same molecule, that is called intramolecular hydrogen bonding. I'll explain the intramolecular hydrogen bonding. Let me consider salicylic acid or salicylaldehyde. You have got that is a C and H, then O. Okay, so let me highlight this CHO. And here you have C, a double bond O, and then O, then H. Okay, so here there will be an interaction between this O and the nearby H because O is the electronegative atom and this is the proximal or the nearby H atom. So that is why there is a chance of bond development and that is hydrogen bond. That hydrogen bond is called the intramolecular hydrogen because within the same molecule it takes place. Are you able to follow? Intramolecular hydrogen bond. So now go through these notes. Hydrogen bonding. Okay. So here, let me go pointwise. Hydrogen bonding is a type of dipole-dipole interaction. So this is a kind of dipole-dipole interaction. Covalently bonded. So this is covalently bonded to a highly electronegative atom. So point number three, it should have necessarily highly electronegative atom. Like example, you can give fluorine, oxygen, nitrogen, etc. That interacts with the lone pair of electrons on another what? That is electronegative atom. For example, it requires a hydrogen atom attached to fluorine or oxygen or nitrogen as a donor. And there should be a lone pair of electrons, so it should be an acceptor. Now, weaker than the covalent bonds. So, definitely this hydrogen bond is weaker than covalent bond, but it is stronger than what? Van der Waals force. What do you mean by this Van der Waals force? Van der Waals force is nothing but the intermolecular force of attraction. So, this hydrogen bonding can be of two types. That is, intermolecular hydrogen bonding and the intramolecular hydrogen bonding. This can take place between molecules, as in the case of water, hydrogen fluoride. But in case of nitrophenol or salicylaldehyde, you are able to get this intramolecular hydrogen bonding within the same molecule. That should be noted here. Okay, right. Now, let us proceed further. Here, what are the effects of such type of hydrogen bonding? So it raises the boiling point and melting point. Why? Because in addition to the van der Waals force of attraction, that is the intermolecular force of attraction, this intermolecular hydrogen bonding, it is an additional force of attraction and that is responsible for what? Elevation of boiling point, that is increase of boiling point and also melting point. So, what are the key effects of a hydrogen bonding? Raises the boiling point or melting point, increases the solubility in water, influences the molecular structure and biological function. So, for example, that is the case of DNA base pairing and the protein folding. Okay, right. Then, now let us consider the differences between the intermolecular hydrogen bonding and the intramolecular hydrogen bonding. So, as I have depicted in this diagram, that is, in this case, you have intramolecular hydrogen bonding. Okay, that takes place within the same molecule. In the case of water, it takes place between the molecules, and that is why it is called intermolecular hydrogen bonding. So, intramolecular hydrogen bonding takes place in this case of salicylaldehyde, etc. Are you able to understand now? Right. Then, now let us see the differences between the intermolecular hydrogen bonding. Um, First of all, definition wise, Intermolecular hydrogen bonding is developed between different molecules, whereas intramolecular hydrogen bonding is developed within the same molecule. Second point, the effect. It increases the boiling point or melting point and also increases viscosity and solubility. But in the case of intramolecular hydrogen bonding, it may decrease solubility and alters the molecule geometry also. Third point, example, water, alcohols, ethanol, etc. Okay. So that is for intermolecular hydrogen bonding. For intramolecular hydrogen bonding, you can take orthonitrophenol and salicylaldehyde. Then fourth point, occurrence. They are common in polar solvents. Which one? Intermolecular hydrogen bonding. Whereas intramolecular hydrogen bonding occurs when donor and acceptor groups are close in a molecule. And then, you should know what about this donor acceptor bond. So in this case, you can see in the case of what you call the intermolecular hydrogen bonding. Here, this is the donor atom because hydrogen that is closer to the, it is going to give the electron and it is going to establish. Okay. So after all, this is not going to donate. This is the donor. Oxygen is the donor and this is the acceptor. Okay. So because hydrogen doesn't have that is a more electron, it has got only one electron and that is also given to this oxygen. But it doesn't have any electron of its own. So in that case, oxygen, it has got a pair of electron and that donates and thereby it establishes a hydrogen bond with this. So in that case, oxygen is the donor and here hydrogen is the acceptor. Okay. Then, and when we discuss about the occurrence, as I already mentioned, this is common in polar solvents, whereas this occurs when donor and acceptor groups are close in a molecule. And strength wise, generally it is stronger due to full molecule interaction, whereas intramolecular hydrogen bonding is weaker because it is limited by molecular strain. And there is an impact on the state also. For example, intermolecular hydrogen bonding helps in forming liquids or network like ice, whereas intramolecular hydrogen bonding, it affects conformation or reactivity of a molecule. Okay. So to summarize, intermolecular means between the molecules, intramolecular means within one molecule. Okay.
Hi students, unlock your full potential with saitechinfo Premium Spark Notes, your all-in-one solution for mastering every chapter.
Get complete chapter notes, printable worksheets, and doubt clinics that clear every concept, every time.
Tackle guided problems, solved exercise questions, and lengthy explanatory videos crafted by experts with decades of experience. Want to go beyond the basics? Face challenging questions frequently asked in NEET, JEE, and board exams and conquer them with confidence.
saitechinfo Premium Spark Notes, where smart learning meets strategic preparation. Subscribe now, learn deeper, score higher.